Hello, everyone, and welcome back to another episode of From the Field. Joining me today is Chris Barron. He is another SA located down in Wellington, New Zealand. I'm your host, Casey Orr, as well. So it's going to be a very interesting time. I believe 2 weeks ago was the last time we aired, and was talking about the floods in Auckland. Well, it seems like we're entering some type of biblical proportion of events because Auckland's flooded again, and I think Hawke's Bay is now flooded. So my heart goes out to them, and hopefully we get through this, without too much damage. But at least it keeps this year interesting. And I think also Wellington had an earthquake last night at 7 p.m. that woke me up. Well, it didn't wake me up,
Yeah.
but it certainly woke me up when I was at my computer. Thought a freight train was going past. Must have been pretty bad for you up in the apartment.
Yeah. I was actually out walking, so I didn't notice it as much. But yeah, it was. I think it was 4.7, I think, or something. Yeah.
That one was a 6. It was
Oh
a
wow.
magnitude
Yeah.
6 off the side of Capri. So
Yeah.
yeah, it's pretty bad. And it also seems like do you get commission for the free advertisement you get in the background there?
Yeah. That was a boring old ad. When I moved here, it was just plain paper, but now it's LCD. So yeah, all sorts of interesting stuff will be happening back there.
At least you don't need to turn the lights on at night. It'll be
Yeah.
full
Save a
blast.
few dollars on the power bill.
Yeah, that's very true. But it's also kind of annoying. I can't sleep when there's lights at all whatsoever. So just to get into it, so we'll be covering off a little bit of the microservice to or monolith to
Mhm.
microservice, sorry, which is kind of like that app monetization type phase where I know that a lot of companies and even just product teams struggle with because there's a lot of that analysis paralysis that comes in, and then there's a lot of risk there as well. So what are you looking to talk about, Chris? And if you want to give a little bit of a background about yourself.
Cool. Yeah. So my name is Chris Barron, and I'm a partner management solution architect based out of sunny Wellington. As they say here, you can't beat Wellington on a good day. That's how we get the tourists to come in all the time. Uh,
It's just never
so
a good day.
yeah. Yeah, what I'm going to be talking about today actually is I'm going to lay out some tools. So it's kind of designed around an actual customer engagement. So you're talking with a customer and they say, okay, we want to modernize our application. It's a big monolithic Java stack or big whatever stack. We want to get started in the modernization. So we're going to be walking through some of the tools and techniques, starting with what you're going to do before you actually start cutting code to get the customer comfortable with the process and just be systematic about it. So you get past some of these analysis paralysis stages. And then we're going to start actually diving in a little bit into the computer science behind how you break some of the stuff up. And we will actually get to throw a few AWS services in there as we look at how some of those patterns would be implemented.
And there's definitely some stories I can add there because as being a .NET developer, there are a lot of modernization stuff that .NET like programmers are going on. It's the framework to .NET Core, and while it is not strictly modernization, it has a lot of the same aspects to it. It's kind of like moving sideways to try to actually keep on the branch that's going to be supported. It's like as I say the was it the framework is like the XP of the .NET world.
Exactly. Yeah. And we all know Windows XP will never actually die.
It will outlive us all. Like
But
the nukes will be fooling,
yeah,
and then there'll be one XP computer turned on with a cockroach next to it.
exactly. But yeah, some of the stuff that we're going to go through as well, we're going to look at breaking up into microservices. So we talk about like independent scalability, and you don't get those situations where, oh no, my website is broken because I have too many views and I can't take any orders. Actually, recent relevant example there. Give a little .co.nz when TV3 was doing their fundraiser. Their page actually went offline when they were trying to raise funds up in Auckland for the initial flood. So, those circumstances, how do we break apart the different parts of the system? So obviously one high volume campaign there took all the other campaigns offline. So how do we break this apart so we can scale each part of the system independently?
Yeah, and it's also quite a common something that happens quite often because there's a what's called the Reddit hug of death as well, where quite often something will be put on there or linked to in the comments, and it will just like completely crash your website.
Yeah, yeah, absolutely. So, yeah, just kind of outline the topics that I'm going to run through. And the what we're going to be looking at here, each of these topics is you could probably spend months in each of these headline activities. So we're going to be at a bit of a 50,000-foot view, but I want to tie it back to kind of a journey you're going to take the customer on. So we should be seeing my screen here, hopefully.
Yeah, I'll just pop it up. There you go.
Cool, cool. So I'm just going to be a little bit drawing some stuff here because I'm sure everybody has seen way too many PowerPoint presentations in their life.
Yeah, it's a great break from
And we'll get to draw some diagrams and stuff too. So we're going to talk about event storming, event sourcing. Then we're going to talk about Fig. We'll talk a little bit about facades and ACL, and then we'll talk about CQRS. So these are some of the tools that you can use to take the customer on a journey. So event storming, this is a workshopping activity, and Casey, I had some links around this as well.
yep.
So yeah, there's quite a lot of reading that you can do around event storming. But the why of event storming, this helps you work with the customer to figure out how many microservices, how big the microservices are. And you're also, one of the key parts of this is you're bringing technical and non-technical stakeholders together to do this activity. And it's actually entirely done with post-it notes and whiteboards. There's no computer assistance for this workshopping activity. And what you want to come out of this with actually is the term that they use is ubiquitous language, i.e., like the business stakeholders, the product owners, the technical implementers, they're all speaking the same language. So, a user is a user is a user, an order is an order is an order. You can all talk the same language, and you've actually modeled out how the system is working. So you're going to start, with your existing monolithic application, and all of these technical and non-technical stakeholders coming together. You can actually model how it works and understand the business process as well. So from that, you put up these stickies of these objects and these actors, and then you draw boxes around there, and those are called your bounded contexts. And those bounded contexts will roughly, loosely represent some of your microservices. So it's not as much fun for us developers because there's not computers involved, but it's a really important step, and it's a really good tool to have in your tool bag when the customer is concerned about how we're going to do this, right? That's usually your first step.
And when you're talking about customers, that's customers from an AWS partner point of view or a service company. This you can also replace customer with your internal business stakeholders as well if you are talking about this from a internal product or a
Yeah, yeah.
service.
Yeah, absolutely. Yeah, if there's viewers, working for companies directly, you could just take these tools and use them to work with your internal stakeholders. The next tool that we're going to be talking about is event sourcing, and this is sort of the crux of the outcome of the microservice architecture. So, event sourcing is often conflated with CQRS that we'll talk about a little bit more. But the concept here is fairly simple. So I'm sure there's some folks on the line that may have worked with microservices architectures before, and you're thinking, I got 100 microservices. That means I got 100 databases. How do I keep everything synchronized, right? How do I stop myself from going insane? So there's many ways to do this as well. There's many different eventing patterns, but event sourcing basically follows the premise that all activities inside of a system are placed on an immutable log, a mutable append-only log for all activities in the system. So you're not persisting these activities, say, directly into a data store. You're persisting them into an event log. And any microservice at that point can generate its own data store by simply replaying the event log. So there's actually a couple of industries, mature industries out there that are naturally event sourced. So if you think about the legal profession, when you write a contract, right, and in it you decide to change the wording of a contract, does the lawyer erase the paragraph and write in a new one? No, they're going to produce an addendum to that contract. Same thing here. Think of how many delete and update statements you have in your program code. Each one of those can mutate your system in a way that you wouldn't know what happened in history. But if you're using an event source model where every activity goes onto an immutable append only log, then you can always replay from any point in time. You can also, in your development environments, you could recreate state of any point in time and investigate what problem happened. You can, alter how the event log happens. So event sourcing, yeah, is just the concept that state in any given microservice is transient, but it can always be created from the immutable event log.
Chris, that log is naturally going to get really big because I can actually see the amount of events any particular system is ever going to emit. So, like, how do you handle like the ever increasing size of that type of like event log?
Yeah, so that's a really good question, Casey. And the technique there is what we would call snapshotting. So we can create a snapshot of the state at say your log is 5 years into history. You can create a snapshot at 1 year, and then you start with that snapshot and replay from that point forward. So that's the technique that you can use, is that snapshotting to help save you from replaying all of history.
So it's actually very similar to what a lot of block storage backup servers do.
Exactly, exactly. Yeah, so it's very similar technique, and then it gives you the trade-off of speed but having the durability there. And you can also pick various points in time, so you can use older snapshots and replay to a shorter term history. So that's the mechanism that you would work with there.
Yeah, and the tech guy says, yeah, like database transaction logs.
Exactly, exactly. Well, when we get down to CQRS, I'm gonna challenge some thinking on the premise that relational databases will solve every problem.
Well, everything solves the problem if you have a big enough hammer, right?
True, true. I guess you can ask Twitter that how big their SQL clusters were before they realized they were actually a pub sub architecture and removed a whole bunch of infrastructure. um, yeah, Martin Fowler actually has some good commentary on this. He calls it unintentional complexity. So, like, Twitter implementing a pub sub model using relational databases just costs massive amounts of compute power. But when you fit the right solution with the right problem and you just implement a pub sub architecture, it's much simpler. Um, so that's event storming and event sourcing. Next, we're going to talk about Strangler Fig, which is a bit of an odd name, as you can guess. Um, this is based on a particular type of fig tree. And what this fig tree does is it has seeds, and birds carry these seeds up into a host tree, could be any other type of tree, and these seeds grab on to the host tree and they siphon off nutrients and slowly grow their own roots around the roots of the host tree and create their own plumes, and eventually they usually kill off the host tree. So that's the strangler fig pattern, and the idea here is that we start with our monolith and we start building out our microservices slowly, and we're slowly strangling off that monolith until eventually we're going to shut it off. Um, so let's take a look at facades and ACLs here. So this is now we're getting into some of the implementation details, right? So this is a strangler fig is a concept that you can help your technical colleagues have confidence in the fact that you don't need to rewrite the whole system in microservices and cut it over in a big bang. Because yeah, nobody wants that life. It's very risky, and you need to have levels of certainty that you can use a strategy to get started and slowly work on that migration as your production app continues to run.
And it gives confidence to the business side of it as well, because for one, you don't have to stop development completely. So you can actually still continue to add features and enrich your feature base and give value to your customers. And it also helps de-risk it because you're not doing that one big bang, as you said. So it works for both sides of the party. And I think that's also why Strangler Fig, a lot of people do Strangler Fig without actually knowing that they're doing Strangler Fig.
Exactly. Yeah, and as I'll kind of sketch up the skeleton of it, right? But basically, Strangler Fig, one implementation of this is a facade. So you have your facade, and then you've got your monolith, and this facade is on AWS. This could be API gateway, it could be an ALB. If you're thinking something open source, this could be an Nginx, reverse proxy, whatever. This is the endpoint, and you're going to pass through all your requests to the monolith. So as time goes on, right, we start to break apart our microservices. I know, Casey, you mentioned a little bit of work that you did, .NET to .NET Core, might be similar to this pattern.
Yeah, actually, just this one image actually brought me back to something probably would have been 10 years ago when I was doing work at my first company, which is actually a Microsoft partner, so I won't name them. Where like they actually had built this real legacy code base, like it was a real massive code base, like it was a bull. It was just convoluted, confusing. No one knew what the hell was going on. So I actually built that facade layer. We call it the blood-brain barrier. And then we built
Yeah,
everything around that, like what was like a more service-based architecture, and then it would just pass things through to um, that confusing code base in the base of it. And yeah, and this is also, as I mentioned before, with the framework from framework to core, this is quite often the route you go through because you naturally have workers or your web server and stuff like that, and then each of those you can slowly peel away. And yeah, essentially you'll be doing this because you don't want to change your whole entire code base at once to .NET Core because it's not a straightforward conversion.
yeah, exactly. Or in software engineering parlance, breaking changes.
Yeah.
Lots of breaking changes.
More like,
No.
oh, this library doesn't work anymore. Okay, we'll have to find a new one for that one. What makes life very
Uh,
exciting and the business very nervous.
yeah. No CTO wants to hear that we're changing the framework.
It also changes how the requests are handled in IIS, which is
Yeah,
exciting because how you inject and those handlers completely change. So like that's really low level things that like affect every single request
yeah.
and can have a
Potential
really weird
call.
behavior.
Yeah,
Yeah,
yeah.
that made me nervous as the person actually doing it.
Yeah, you're just like, oh, did my find and replace work everywhere? I don't know.
Hey, we only we only did production once and it was fine.
Yeah, going back to our example here. So yeah, like you mentioned, most people have probably done this in the past. They just didn't call it strangler fig pattern, or like I said, there's many implementations. So this is going to be the facade and ACL implementation. So there's many others that you can look into. And yeah, like I mentioned, these are huge topics. So we could spend weeks on all of these things. Um, so here in the monolith, let's say we've got some functions. Let's say orders, products, and inventory. um, this is fairly simple. Like say we build out ourselves an orders microservice. You can see how bad my handwriting is, but
While you're doing that, Martin does actually ask a question. Do we point the DNS records to the facade layer?
yes. So the idea with the facade is, and this is a good call out as well. Say you wanted to use API gateway for your facade. Couple of things to consider here. We have a 10 MB megabyte payload limit and 30-second timeout for the monolith to respond. So what I would do, production app wise, is go through your logs. If you can fit these constraints, then you're going to create an API gateway, and inside of the API gateway, you're going to use the proxy plus greedy operator to pass everything through. Once you have that set up, then so let's just say that this is mon.app.io DNS wise, and then this is your let's see, I'll just say that's fac.app dot oops io, and then say you have your app.io as a CNAME record. You'll just change that CNAME to from pointing to the mon over to pointing to the facade. So yeah, you're going to change your DNS once this is built, but you can build all of this and test it without making it live. But yes, your cutover to live is going to be changing the DNS. The facade, what's important about the facade is it gives you URL based routing. So you're not going to have different DNSs for your, you wouldn't use different DNSs for your monolith and your facade. You'd only have the facade take over that entire record, and then it does path based routing. Hopefully that answers the question.
And I'm just going to say that you could have become a doctor with your handwriting. It's amazing.
Yeah. That actually comes from America, because in America we don't believe in pins for credit cards, so we have to sign our signature every time we buy something. So just get a little doctor
So
action going on.
it's like, do we have to match the signature? Nah, so
Yeah,
secure.
I I said at the beginning of the presentation it was going to be fun to do the diagrams. I didn't say it was going to be pretty, so.
Mm. Or legible, apparently.
So yeah, if we think about like in this case, like if we have a slash orders slash x, and then or like slash sorry order x, if we're doing oops, order slash x or orders, we'll route these over to our microservice, and we'll leave the rest of the URL traffic going over to the monolith. Um, so now we're going to touch on a little bit, getting us into our next topic, because as you can see, routing the URLs, that's fairly trivial, right? Like I've got my new microservice, easy. Now the fun part is, where's the data, right? Like if I create an orders microservice, and if this thing doesn't have its own data store, um, and you're pointing back to the monolith, for example, like you really haven't created a microservice, right? You still have dependencies on the monolith. So each of these are going to have their own data stores. So what you're actually going to have to do, because like think about when products here calls orders inside of your monolithic application. That's where you need the ACL, the anti-corruption layer. So you're going to build, a class. You're going to build an orders class in your monolith that makes the calls out to the orders microservice. But what's important with this anti-corruption layer is that you cannot force the orders microservice to have the same schema as the monolith. So the way you build your orders class and your monolith for this corruption layer has to give you complete flexibility to change how the data is stored. And that's the key to the anti-corruption layer strategy. So there are quite a few more strategies to manage data between the monolith and the microservice, and they're get pretty deep into various methods. But yeah, for the scope of the show today, that's probably as far as we'll get, unless there's any other questions about the facade and ACL.
Oh, one just as you pop through, so that's great timing. But
Cool.
were you forced to share the IDs in the database? That actually makes sense
Um,
because there will be referential integrity that you need to maintain.
yeah. So here's the thing. You need to be able to recall the correct record. Now, whether that means that the ID itself is the referential integrity, or maybe you added a GUID into your monolith, and then you copy that into your microservice. Like you don't have to necessarily copy the IDs from the original database. You just need to have something that you've introduced by means of the ACL that allows you to find that record. Um, so that way, that gives you more flexibility. Because maybe in the microservice you want to use GUIDs instead of integers. That's fine as long as your ACL can translate from the old ID to the new object when it calls the order service. So does that make sense?
Yeah, that makes sense to me. And also, one thing there, which is quite interesting that a lot of people don't think about, is that an auto incrementing ID that is surfaced to the front end is actually considered bad practice, because it means that now, if you have like a URL that goes /ID, you can just play around with that ID and see if you can get access to, either incomplete records or someone else's records. And it just means that it's just, how do I say this? It's
Yeah,
just that one.
reduces your security essentially, right? Because then you
Yep.
can just walk the records in sequence. So yeah, that would be actually a really excellent use case there for introducing a GUID um, inside of the microservice. But strictly speaking, the ACL's responsibility is to make it so that the orders microservice has complete freedom. So yes, you need to have some way of referencing a record, but that doesn't necessarily mean that you need to copy the schema from the old to the new. You just need to have code that can do the translation. It could still very well be that you keep records in your monolithic database that has the old ID with the new GUID, and then the ACL knows that it needs to use the new GUID when it talks to the microservice. That's fine. But you've transferred the responsibility correctly, and you haven't forced the new service to have any schema attributes of the old. So all of these things, we're just talking about them from a computer science perspective, right? Like that doesn't stop anybody from implementing it badly. As soon as you've created a situation where the microservice depends upon the monolith, you've actually broken the computer science concept, which means you will suffer some future pain as you're implementing. So that's why some of this stuff is a lot of fun, knowing the computer science concepts, because it's going to really help you when you're actually on the ground implementing, not to make bad choices, because it might actually be easier to implement it that way. As the caller mentioned, maybe you're just like, I'm just going to copy the ID over. And then, yeah, your security team gives you crap. Like you said, Casey, I want that to be a GUID. And then all of a sudden, I've got to deploy the monolith to update my microservice because I interlock schemas, right?
Yeah, the other logical one that would be come up a question I know that some people will probably think about it but haven't asked, is that what if orders needs to interact with the monolith in terms of getting something done? Like, how does that look? Is that going through the anti-corruption layer, or is that just going back out and through the proxy?
So it is perfectly valid for, or sorry, yeah. So if orders need its information about products, yeah, it will use the anti-corruption layer or the front end. Yeah, it's good. Sorry, it's going to use the anti-corruption layer because it's not the microservice cannot take a dependency on the monolith. The
Yep.
monolith can depend on the microservice, but not the reverse. Yeah. So you'd use
Yeah.
the ACL for that.
Because I say that when you do have those dependencies in place, what you haven't actually done, you haven't created a microservice, you've created two micro monoliths.
Yeah, yeah. So, and that's a really good point, Casey. It's really easy to create a distributed monolith, which now gives you all of the pain of a monolith and additional complexity, because a distributed monolith is much more complicated and harder to maintain than a plain old monolith. So yeah, you do really need to watch out, and it's really these subtle conceptual things that are going to save you from inadvertently creating a distributed monolith. So yeah, excellent question.
Yeah, and doing a release with distributed monolith is a nightmare, because you essentially because everything is dependent on each other, you have to do and like everything has to update at the exact same time. and
Exactly.
nothing updates at the exact same time. So you have to have this weird convoluted thing where like you have to have both servers up and running and then directing traffic. You have to have essentially have a router in place just for your updates.
Yeah.
That's
Yeah, and that's yeah, it's a really good point. In that when we're quantifying these systems, right, we talk about coupling and cohesion. So the point of microservices is to have low coupling and high cohesion. As soon as you've created release dependencies, you now have high coupling, and now you're running into that distributed monolith territory. Because if you have three microservices and they can't deploy independently, then they're a distributed monolith. They're not microservices because they have high coupling, and in that case, low cohesion. Cool. So the next topic that we were going to cover off, so this was the facade layer and ACL. Actually, I'll take a quick second to talk a little bit about a program that AWS runs in the partner space. So we have this program for Advanced Plus partners called Black Belt. And the idea with Black Belt is we have a whole bunch of different tracks for you to get training from AWS in specialized skills. And then you actually get one-on-one time to work with an AWS SA to validate those skills. And then we have some credentials at the end of that that you can use as you're working with your customers. And one of the tracks actually is what we're talking about here. It's called Developer Acceleration. So anybody who's on the line that works with AWS as a partner, talk to your local PDM because we will have iterations of this running various spots across the globe, and we spend a whole week working through all these concepts. Actually, a bit more than what we talked about in the initial agenda, but it's really good course.
and while you was going through that, there's one other question that came through is like, are you forced to use XA transactions? How will they be implemented in a monolith that uses microservices?
Cool. So one of the there's quite a bit of implementation detail of um, dealing with transactions in microservices. So in your monolithic database, it's really easy to just run ACID transactions, right? You have a SQL engine that manages it for you. Begin trans, do your operations, end trans, and it either all succeeds or all fails. In the microservices world, we have a tool called Sagas. We probably won't have time to go into detail with Sagas, but they're methods of doing distributed transactions. So, in other words, how do I coordinate between three different microservices a transaction? So that there's a tool for that called Sagas. So in your monolith, if you're dealing with this, that will be part of the responsibility of your anti-corruption layer. So if you have one of the pieces that you've migrated, say orders is migrated and it belongs in a transaction when you do process order, your anti-corruption layer is going to have to manage the locking with the microservice for that transaction. When it's fully distributed, then you're going to use a concept called sagas, and there's choreography and orchestration and ways to work through that. So excellent question. But yeah, I'm going to cover a little bit of CQRS instead of sagas because it's pretty interesting, and then we get to talk about a little bit about bringing it back to event storming.
So, and he also then replied with, so monolith will be the orchestrator in Saga pattern.
Um, yes, yeah, the monolith would be the orchestrator in that case.
If we get enough time towards the end, like once you've gone through the secure pattern, if we're doing enough time, let's dive a little bit deeper into the Saga stuff because it looks like there's some interest in that. So yeah, hopefully we can power through this and then get to some of the
Yeah,
Saga
yeah,
content because we still have like 25 minutes, which should be more than enough.
cool. All right, yeah. Sounds like a good plan. Sounds like a good plan. So, yeah, CQRS. What this stands for is Command and Query Responsibility Segregation. This is just a really fancy way of saying we're going to separate the reads from the writes. So if we blow up our orders microservice, um, what we want to be able to do is we want to come up with two different paths. There's a command path and a query path. Now, when we talk about event sourced systems, commands are events that are directed that mutate the system. Queries are activities that don't mutate the system. Each of these is going to generate events, and events are observable and they do not mutate the system. So this is getting, yeah, slightly complex because we're diving in a couple of layers here. But basically, if I think about my order system, I want to have a different data store for my reads than I do for my writes. And actually, what might make more sense for this, because it might be simpler to think about, is I'm just going to call this products. Because let's think about our earlier example. Give a little, let's say that their campaign page is down. So from a read perspective on products, I want to have a data store that's really fast at doing reads because maybe I want a million requests a second. So I want to say use something like a Redis here. I want to do a in-memory key value store for my data store for my read workloads. But for the writes, I'll be nice. I'll just say this is just a SQL database up here. We could use a NoSQL data store like Dynamo, or we'll just call it a SQL database just for fun. So what happens here is when we go to write into products, we go down this command pathway. The command pathway writes a record to its data store, but then it also emits an event to a bus. And the query interface here observes events from the bus. So this is how we're actually able to create a loosely coupled, highly cohesive replication strategy between those two data stores. So some people might say, how is this different from a SQL server and a read replica? Well, a SQL server and a read replica means that read replica has to have exactly the same schema as the original data store, and it actually has to be running on the same engine as the original data store. So they're actually tightly coupled if you think about a SQL database and a read replica. In this case, these are loosely coupled because we can choose any data store engine that we want. And the way that we synchronize them is through the use of messages. And like I touched on with event sourcing, there's a whole bunch of different strategies around messaging. But in this way, we this read data store here actually is only eventually consistent. By the way, it's not strongly consistent, but in most use cases, that's fine. And we see that a bit with S3. We see it with Dynamo. You can actually choose if you want to have strongly consistent reads versus eventually consistent reads. Yeah, we kind of flew through this. Any questions on this?
Someone did mention it's like building a cache strategy, which I'd say it's kind of is, but kind of isn't.
Yeah, it's not a cache because the schema in this Redis database doesn't have to match the schema here, because you might actually denormalize a record. If you think about a SQL database, the product may have many attributes, and it also may have many, I don't know, metadata, like has many metadata, and that's a different table. And in SQL, you'd store that as uh, as a normalized record, right? But when you brought it into Redis, you might actually just denormalize it because you want it to be faster. So it's not a cache because you have the choice of how you want to represent the data differently.
Yeah, and JW also has mentioned that if you're adopting the strategy for a existing system or database, then yeah, you will need to precede your other data store, data store, because um, as mentioned before, it's not like a pull-through cache. It should have all of that data represented there already. Is that correct,
Yeah,
Chris?
and yeah, when you're thinking about your initial implementation of this, yeah, you could do a couple of strategies. What you could do is if you wrote, we're getting fairly down into implementation details, but let's say that you wrote a event handler function here that was that ran after an activity from a SQL insert or update, right? What you could do then is you could call this table and then reload it and force that event handler to then emit all the events on the bus to generate your initial load. That's probably a lot safer than trying to by hand bring the records across. But yeah, you're going to, if you have the existing data store, you're going to need something that will collect history if you care about history. If you don't care about history, you could just continue on from that transaction point forward into the new data store. So yeah, it depends. But that, that's one implementation strategy, for example.
And convenient enough, he also recommended the black belt program, which that's always good to hear.
Excellent, excellent. Yeah, I'm sure we'll have some folks on the line that have been through it, partially with me and some other great essays in AWS.
None of them are as good as you, Chris. None of them are as good as you. Cool. So, I think we have some time before any other
Yeah,
questions come through. Do you want to jump into the Sega stuff, going through the orchestrators and
yeah,
what's the other one?
choreography,
Oh, yeah, that's the one.
yeah.
Yeah, no, that's why I never became a dancer. I can't remember the terms.
um, yeah, so let's save that. So now talking about distributed transactions. Now we're going to do a little shout out back to our event storming. So remember, in event storming, we're actually trying to find our bounded contexts. So one of these might be orders. This might be fulfillment. Yeah. So choosing a saga pattern, what you're generally going to do is you're going to use choreography between bounded contexts, and you're going to use orchestration inside of a bounded context. And this makes sense because when we look at these strategies, an orchestrator actually has to have a fair bit of implementation details around the microservices it's working with. So if we used orchestration across the bounded context, you're violating its single responsibility principle because it's going to have information about an adjacent bounded context. So now we're increasing coupling in that case. So remember, simple fact, orchestration inside of a bounded context, choreography between a bounded context. So let's take a look at what these look like. So the simpler version is choreography. And I can't actually spell that, so
Don't ask me either. I'm terrible at spelling.
this is why I type things, because I have spell check and it fixes it for me.
Just put a red squiggly line under it, and then we know it's spelled wrong.
So in choreography, basically, let's say we have let's go order, oops, product, and inventory. So let's say with choreography, you get an order. So we do an order create command. The order microservice knows that the next step that it needs to do is it needs to call the inventory service and make sure that inventory is available. If inventory is available, then the order service then will or actually we should probably just make it so that inventory calls. It's a lot simpler if inventory just calls products. So order calls inventory, says, is inventory there? If inventory is there, then inventory calls product to get, I don't know, actually, that's, sorry, this is a complicated example. Let me think about a simpler one.
While you're doing that, we've also been told how to spell choreography. So CHOREGARAPHY.
G, after G, where are we?
GRA
PHY.
PHY. There we go. Look, as a team, we're much better. We just have to rely on other people.
um, all right, yeah, so let's do order product payment and payments. So in this case, an order comes in. The order is going to use the product service, and that's going to tell it if there's inventory. If there's inventory, the product service is going to say, go process the payment. And the payment system finishes, it's going to report back to the order that everything's okay. So likely what you're going to do is have message buses in between here. That's one implementation option. You could have API calls, whatever you want to do there. What's important here is say that payment fails and you need to roll back. Well, payment then needs to know the compensating transaction to tell the product service to roll it back. So release the inventory. And then the product service needs to know the compensating transaction to go back to the order service to tell it the order failed. So choreography is that the microservices know which one is next in line, and they know how to reverse the transaction to the previous microservice. So you can see this is useful for very simple transactions. And because in the event we're crossing a bounded context, we don't want any implementation details leaking between the bounded contexts. So we're kind of stuck with choreography. But a bounded context will be something like order and then fulfillment. So likely there's not a lot of data overlap, right? So it makes sense why choreography is more useful between bounded contexts. Now with orchestration, actually, any questions on choreography before we look at orchestration?
Actually, do we even know how to spell orchestration?
Good question.
We are a terrible team. Holy, there
I
we go.
think so, but
Yeah, don't worry, I fixed this one in advance. I got it ready to go for us. No questions had popped through, so let's just jump through
cool,
the
cool.
orchestration,
Well,
which
this is
is
an excellent example, Casey. That this is not a scripted show on purpose because we want it to be fun for the audience. Because if they can't have a laugh because we can't spell things, I mean.
yeah, English is only our first language. It's fine. And if you spell it with such a terrible handwriting, no one can tell if it's spelled wrong or
There we
not.
go. So orchestration, this is a Saga pattern where you make the command to an orchestrator. And that orchestrator actually has implementation details of the various services. So that's our order, product, and payment. So in this case, the orchestrator will call the order service, get a response back. If that's good, it'll call the product service, get the response back. If that's good, then it'll call the payment service, get the response back, and then that will return a successful completion of the saga. So the orchestrator also knows the various compensating transactions. So if the payment failed, it knows how to roll back product and it knows how to roll back order. Now, generally speaking, if we think about choreography, choreography has the benefit of the fact that there is not a single point of failure, because with those microservices, if one of those microservices in the chain actually goes down, when it comes back up, that work will be replayed and it'll continue on. So there's not a single point of failure in choreography. Also, why it's really important to use choreography between bounded contexts. Now, in the case of orchestration, there is a single point of failure, which is one of the cons of orchestration. However, I've got an excellent piece of news there. We have the service in AWS called Step Functions, which is a highly available, highly scalable service that is excellent choice for implementing orchestrators. So we can actually mitigate that risk of a single point of failure for you using some of our serverless tech that deals with the undifferentiated heavy lifting of high availability for you. And actually, step functions is perfect for orchestration because you have it manages all the JSON data payloads. It does retries. You can actually map out. If you've played with step functions, you actually map out the 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 branch conditions. It can do multiple parallel steps. It's got a lot of really awesome capability for being an orchestrator. So, oh yeah, go ahead, Casey.
I was just going to say, one of the things that in uni that really excited me, because apparently I'm just a weird child, was the finite state machines.
Yep,
And
yep,
that is just what step function is. It's a finite state machine. And
exactly.
yeah. So like I just absolutely love the service because I'm just nerdy like that.
Yeah, yeah. No, it's really, really cool service. And yeah, it's a really good implementation of the state machine. If you actually look, I don't know if it's still the case, but old console URLs, if you went to step functions, the URL would actually be state machine instead of step functions. I don't know if we changed that in the console, but
It's hard to get away from the roots. There's a question in choreography. What is payment service? What if payment service takes forever to reply? How long does order service wait? Same timer. So essentially, it's a distributed systems question.
yeah. So in dealing with communications between the microservices, you're going to have to accept some level of delay. What you would normally do actually in the case of choreography in that example, um, you there's a concept of a pivot transaction. So in this case, we know payment is expensive time wise, but also if the payment fails, it's a lot of work to roll it back. Whereas if you're checking the product in inventory, it's not expensive to roll it back because we haven't moved around money. So you might actually design your choreography around the payment being the pivot transaction. So you may want to redo the ordering a little bit because if that fails, you may want to know that information earlier and be able to, you know, sorry, if that payment is the pivot transaction, the other things preceding it, like checking inventory, um, you want that's easier to roll back. So you want to get that done first, and then that payment processing after you know everything else in the transaction is done. But yeah, time wise, your each of your services has to tolerate the other services being down. How long that will be for will be up to you. You'll manage that if you had like message buses in between, how long you might wait before something is replayed. Um, yeah,
For
and
example, like the proxy plus overload for API gateway is 30 seconds. That's like a hard 30-second cutoff.
oh
See
yeah,
if I
yeah.
can answer, I don't.
Well, so yeah, in that case, right? If we placed the order, placing the order is a command, so that was directed, and that required a response. So what you could do, so to mitigate this, right? Like if you place the order in the UI, when you actually place the order, instead of expecting the order to complete a 200 OK, you could just have it create a new order in a pending state. And then in the UI, you'll see that it's pending. And now that's just decoupled you from having to wait that 30 seconds. The UI just shows the order is pending, and then off goes the transaction, does all its crunching, and then it'll eventually update the order record, in which case you check again, and that order will go from pending to processed, right? So you can break that apart. You don't have to expect a response there. You can create that in a pending state and then let the work happen.
And most microservices, you move towards an asynchronous relationship for that
Exactly.
exact reason.
Yeah, yeah. So that's yeah, a really good point is that in distributed systems, you have to accept eventual consistency. There are certain cases where you have to have strong consistency, but strong consistency means you're going to lose the ability for a service to fail in that chain, right? Because if it's strongly consistent, then that service has to respond. So, like price changes is probably something that you're going to expect to be strongly consistent, not eventually consistent, because you don't want people buying the same product when you're changing the price, like you want that to be completed in a strongly consistent fashion. But maybe you can accept it as an eventually consistent fashion if your business changes its price once every 10 years, like then an extra 2 minutes, and some people got a different price for a brief period in the system's history. Oh well, so you got to do some of those trade-offs. There's techniques as well to help you with strong consistency without and still giving some of the distributedness to the transaction. um, so yeah, you can use the term is escaping me, but yeah, there's methods to help you with that.
Yeah, just gonna we got like 3 minutes left, because we do have a hard cutoff at 1 p.m. And sorry, 2 p.m. Oh, I don't know what time zone I'm in. So if you have any questions, now's your time to ask. In the meantime, I actually do really want to thank you, Chris, for coming on the show and actually showing us and sharing your knowledge around all of this. Do you want to do another little shout out to the Black Belt program while we wait?
Yeah, yeah, absolutely. So, yeah, as I mentioned, we have this program called the Partner Network Black Belt Program. And this is, we have various different technical tracks to this program. And the idea is to give you training to be 300 to 400 level experts in specialized topics. So all the material that I covered here today is part of the Developer Acceleration Black Belt program. And in that, we actually spend a week long doing training and really deep diving into all these topics. And at the end of that, you do a 1 hour interview with some coaching from AWS SAs to validate that you've learned the skills for this black belt. And then, we also give you, as a partner, we give you help with go to market. And we have we don't the black belt program is still a bit in pilot, so we don't have all the stuff built out yet, but there will be a web page similar to the APN ambassador program where it shows that you're a black belt and what area you're black belt in.
And they was also asking about Canada general public sign up for a Black Belt program. At the moment, it's only for Advanced Plus partners, right?
Yeah, practitioners inside of advanced plus partners at the moment, unfortunately.
Yeah, I think in New Zealand, like depending, like if there might be a possibility of running one or two outside of the partner program, just because if there's enough demand. But yeah, in the meantime, it's still fairly early days for it, right?
Yeah, yeah. Yeah, we're still working through. It's still a beta program, but we're hoping to get bring it to GA in this coming year, hopefully.
Awesome. Again, thank you very much, Chris, for sharing, and also thanks for everyone that is watching and asked all of those wonderful questions. It was lovely having answering that and having everyone here. So thank you. Actually, one last question just before I go. Anything equivalent for the general public?
There is some URLs. The DevX team actually has produced a bunch of lab content that's available to the general public. So that's roughly following some of the stuff that we did. I will have Casey. Do we have a offline way of giving out that URL after the broadcast?
If you can send me the URL, I can post it in the chat just
Yeah,
before
yeah.
we bow off. And JW is also asking if you get paid for that waffle ad in the background. Those ads, man, they get so much free airtime.
Yeah, yeah, yeah. It's fun. It's fun until it's bedtime. I just sent you that in Slack. There's the DevX Academy monoliths to microservices. So these cover off some of these workshops um, to give you some of that information. And the DevX team is available as well. If you want to search for them, they can help you with proof of concepts and such as well, just as a customer directly.
Cool, awesome. With that, we do actually need to jump off air before I get in trouble for invading someone else's time slot if there is one. Thank you very much, everyone, and thank you very much, Chris.
Cool. Thank you
Yes,
for having me.
awesome. Cheers, and see you later.